Welcome back, everyone, to another deep dive.
Yeah.
Today, we're going on a journey into the world of AI civilizations.
Oh, wow.
Buckle up, folks, because things are about to get
Yeah.
really interesting.
I bet.
We got this incredible technical report from Altera, AL,
Okay.
called Project SID, Many Agent Simulations Toward AI Civilization.
Interesting.
And it's filled with some mind-blowing experiments that are
Really?
pushing the boundaries of artificial
I
intelligence.
can't wait to hear about it.
So what I think is really captivating about this research is that
Right.
we're moving beyond just teaching AI to perform tasks.
Right.
We're now trying to simulate entire societies of AI agents,
Yeah.
complete with their own cultures,
Oh, wow.
and even religions.
That is pretty wild.
Yeah, it sounds like something straight out of science
It
fiction,
really does.
but it's actually happening right now.
That's amazing.
So before we dive into the nitty-gritty,
Okay.
can you explain what exactly an AI civilization is?
Sure. So in the report, they define it as an advanced society with specialized roles,
Okay.
organized governance,
Mm-hmm.
and advancements in areas like science, art, and even commerce,
Wow.
mirroring the key elements we see in human civilizations throughout history.
So it's not just about creating like a bunch of super intelligent AI agents.
Right.
It's about understanding how they can coexist and thrive together.
Exactly.
Kind of like a digital mirror reflecting our own societies.
Yeah, a really interesting way to put it.
So the researchers believe that building and studying these AI civilizations
Yeah,
will be crucial for a future where AI is seamlessly integrated into our world,
definitely.
but it's no easy feat.
No, it's not.
So what are some of the biggest challenges they're facing
Hmm.
in creating these AI societies?
Well, one major hurdle is something called the hallucination problem.
Okay, the hallucination problem.
You see, LLMs and agents can sometimes generate incorrect information.
Mm-hmm.
It's like they're hallucinating.
So imagine an AI playing Minecraft and thinking it just ate a bagel,
Yeah,
even though it's actually done nothing of the sort.
exactly. And the problem is that these hallucinations can have a ripple effect.
Mm-hmm.
They can contaminate the data and lead to a cascade of errors,
Oh, wow.
not just for the individual agent, but for the entire group.
Yikes. That sounds like a recipe for chaos.
It can be.
What else are they struggling with?
Another big one is the coherence problem.
The coherence problem.
It's all about keeping an agent's behavior consistent.
Okay.
Think about it. AI agents have multiple ways of interacting with the world.
Right.
They can chat, take actions,
Yeah.
and process information all at once.
So it's like if I said I was going to grab you a coffee,
Okay.
but then wandered off to watch a movie instead.
Uh,
Totally mixed signals.
Yeah, exactly. Imagine an agent named Abby who agrees to give another agent a pickaxe.
Okay.
She might say sure thing with her chat module,
Right.
but then her action module does something completely different.
Right.
This lack of coherence can cause major misunderstandings and breakdowns in collaboration.
Then I'm guessing measuring progress in these AI societies
Yeah.
isn't exactly a walk in the park either.
You're right. We have benchmarks for measuring how well individual AI performs.
Okay.
But how do you measure the success of an entire AI civilization?
Yeah, that's a good point.
That's another big challenge they're grappling with.
It's like trying to judge a basketball team based on the skills of individual players
Right.
without ever seeing them play a game together.
Exactly.
So how are the researchers tackling these roadblocks?
They've developed a new AI architecture called Piano,
Piano.
short for Parallel Input Aggregation via Neural Orchestration.
Piano. That sounds almost musical.
It is actually.
Is there a reason for that name?
The idea behind Piano is to create harmony and coordination between all the different modules within an AI agent.
Okay.
Imagine a conductor leading an orchestra.
Interesting.
That's what Piano aims to do.
I'm starting to get the picture. Can you break it down a little further for me?
Sure.
How does piano actually work?
Well, it operates on two key principles,
Sure.
concurrency and coherence.
Okay, concurrency and coherence.
Concurrency is about allowing different modules within the AI agent to operate in parallel
Mm-hmm.
at different time scales.
Yeah.
Think
Yeah.
about the human brain.
Yeah.
We can walk and talk at the same time
Right.
because different parts of our brain are working concurrently.
So it's all about multitasking AI style.
Precisely.
And then there's coherence.
Right.
This is where the magic of piano really comes in. It
Yeah.
introduces a cognitive controller that acts like a central decision maker.
Okay.
This controller takes in information from all the other modules,
Mm-hmm.
analyzes it,
Right.
makes a decision,
Yeah.
and then sends that decision back out to make sure all the modules are in sync.
Exactly.
So it's like a control tower, making sure all the planes are landing safely and on time.
That's a great analogy.
No more mixed signals or AI agents wandering off to watch movies when they're supposed to be fetching coffee.
Exactly. That's a great way to put it.
This cognitive controller helps to resolve those coherence issues.
Yeah.
And ensures everyone is on the same page.
Definitely.
Now, to test out Piano and see if it could truly create a thriving AI civilization,
Right.
they needed a suitable virtual world.
Yeah.
So where did they choose?
Okay.
Some super advanced, hyper-realistic simulation.
Well, they decided to go with
Okay.
Minecraft.
Wait, Minecraft, the
Yeah.
game with the blocky landscapes and pixelated creatures.
Yes. As surprising as it might sound,
Yeah.
Minecraft is actually a perfect testing ground.
Oh, okay.
It's open-ended,
Mhm.
allowing agents to explore and interact freely.
Right.
It's also scalable,
Okay.
so they can easily add hundreds or even thousands of agents.
Mm-hmm.
And importantly, it provides clear ways to track progress,
Okay.
like through item acquisition.
Interesting.
You can think of it as measuring a civilization's technological advancement.
I guess it's a bit like starting with a blank canvas. But before they could unleash hundreds of agents into a virtual Minecraft world,
Right.
they had to make sure the individual agents
Yeah.
could actually function effectively, right?
Exactly. They started with smaller scale experiments,
Okay.
dropping 25 agents into different Minecraft environments
Mm-hmm.
and tasking them with being explorers,
Okay.
gathering as many different items as possible.
Interesting.
This was their way of testing individual performance.
And how did they do?
Yeah.
Did these AI explorers manage to navigate the blocky landscapes
They
and
did.
gather all the goodies?
They actually performed remarkably well,
Oh, wow.
especially the agents using the full piano architecture.
Okay.
They were able to acquire a significant chunk of the available Minecraft items.
That's impressive.
The cognitive controller really seemed to help them stay focused
Hmm.
and avoid those troublesome hallucinations.
So no more AI agents hallucinating bagels in Minecraft.
That's right.
That's good news. But there had to be limits to their individual progress, right? They couldn't just acquire everything in the game.
You're absolutely right. They conducted a longer experiment with 49 agents
Okay.
and observed a fascinating pattern.
What was that?
The agents consistently hit a ceiling in their progress,
Oh, interesting.
acquiring only about 1/3 of all the possible Minecraft items.
That is interesting. Why do you think that happened?
Well, it suggests that even with advanced AI like
Yeah.
Piano,
Yeah.
there are inherent limitations to individual learning and acquisition.
Okay.
It's a reminder that mastering an environment completely,
Right.
even a virtual one,
Mm-hmm.
is incredibly complex.
Yeah,
And if you think about it, it kind of mirrors the limitations we see in the real world.
that's true.
Even the most advanced human civilizations
Yeah.
haven't achieved absolute mastery over their environments.
Yeah. It adds a touch of realism to the whole thing, doesn't it?
It does.
So individual performance check.
Hmm.
But what about social intelligence?
Right.
Could these agents actually interact and form relationships?
That's a great question.
That's what I'm really curious about.
That's where things get even more fascinating.
Okay, I'm officially intrigued.
To test their social intelligence,
Yeah.
the researchers put the agents through a series of experiments
Okay.
designed to see if they could understand and respond to social cues.
What kind of experiments did they run?
They started with a scenario that I like to think of as a virtual high school drama.
Okay, a virtual high school drama.
They placed an agent in a room with 3 characters
Mm-hmm.
who expressed different sentiments towards the agent,
Okay.
changing their feelings over time.
Oh, wow.
It was like a complex social dance
Right.
with the characters' emotions shifting and evolving.
So the AI agent had to navigate a world of shifting alliances and frenemies.
Exactly. And the agents with social awareness modules
Mm-hmm.
were able to track these changing sentiments remarkably well,
Okay.
showing they could understand the nuances of social interaction.
That's impressive.
They weren't just robots blindly following instructions.
Right.
They could actually read the room and adapt to the social dynamics.
Okay. That's pretty impressive. But were they able to use this social information to make decisions?
Hmm.
That's the real test, right?
You're absolutely right to explore this. They designed a clever experiment that they called the chef experiment.
The chef experiment. Okay, I like it already.
They put a chef agent in a group with other characters who had varying levels of affection towards the chef.
Okay.
The challenge for the chef was to distribute a limited amount of food
Mm-hmm.
amongst these characters.
Okay, now I'm on the edge of my seat. Did the chef just split the food evenly?
Mhm.
Or was there some strategy involved?
What they observed was fascinating. The chef agent didn't just randomly dole out the food.
Okay.
It consistently gave more food to the characters it perceived as liking it more.
Wow, so they weren't just understanding social cues,
Right.
they were actually using that information to make decisions.
Exactly.
That aligned with their social goals. It's like
Yeah.
they were developing a rudimentary form of social strategy.
Precise.
And to see how far this social intelligence could go, they decided to scale things up,
Okay.
creating virtual societies with 50 agents,
Wow.
each with its own unique personality.
Yeah, that's really interesting.
They let these agents interact freely in a Minecraft world
Okay.
for over 4 hours,
Quite-
observing how they formed relationships and built their own social structures.
That's amazing.
Okay, this is where things could really get interesting.
Yeah.
What emerged from these larger simulations?
So while the report doesn't delve into the specifics like AI love triangles or power struggles,
Right.
they did discover that even in these unconstrained environments, the agents exhibited some remarkable social behaviors.
Like what?
They accurately inferred each other's likability,
Okay.
building on those social awareness skills we talked about earlier.
Right.
They even showed variations in their social connectivity based on their personalities.
Oh, wow.
For example, introverted agents consistently had fewer social connections, just like we often see in human societies.
That's incredible.
Yeah.
They weren't just bouncing around randomly. They were forming social structures that reflected their individual personalities.
Exactly.
It's amazing to see how these basic building blocks of social interaction
Yeah.
can lead to such complex patterns.
It is.
But could they go beyond these basic interactions?
That's the question.
Did they form something resembling a true civilization?
That's the million-dollar question. And to answer it, the researchers focused on 3 key elements:
Okay.
specialization, collective rules, and cultural transmission.
Okay, that's specialization, collective rules, and cultural transmission.
And that's what we'll dive into next.
Perfect. Can't wait.
Yeah, Brett.
I'm already hooked. Welcome back to our deep dive into the fascinating world of AI civilizations.
Yeah.
Last time we left off with the question of whether these AI agents could move beyond basic social interactions
Right.
and exhibit the hallmarks of a true civilization. And you said the researchers focused on 3 key elements:
Yeah.
specialization, collective rules, and cultural transmission.
That's right.
So let's start with specialization.
It's a great place to begin because in human societies,
Yeah.
specialization is key.
Right. We have farmers, doctors, teachers, artists.
Exactly.
Everyone has their own role to play, contributing to the overall complexity and success of the society.
Yeah.
So the question was, could AI agents achieve a similar level of specialization?
That was a big question.
So did they just throw a bunch of AI agents into a virtual world and hope for the best?
Not exactly.
Or was there a more structured approach?
They took a very deliberate approach,
Okay.
setting up a fascinating experiment in Minecraft.
Right.
They placed 30 agents in a virtual village,
Okay.
a pre-built environment with various resources and locations, like a farm, a mine, a forest, and even a town hall.
It sounds like they were setting the stage for a classic village building simulation game.
Exactly. The agents were given a shared goal: to survive and create a thriving village. But the researchers didn't give them any specific instructions on how to achieve that goal.
Right. So no guidebook.
No guidebook. They wanted to see if specialization would emerge organically.
I'm hooked.
Mhm.
What happened? Did these AI villagers just wander around aimlessly?
They didn't?
Or did they actually start taking on different roles?
What they observed was truly remarkable.
Okay, tell me.
Without any explicit instructions, the agents began to specialize into a diverse range of roles.
Wow.
They had farmers who focused on gathering seeds and tilling the land,
Okay.
miners who ventured into the depths to extract resources,
Cool.
engineers who crafted tools and structures,
Really?
and even guards who patrolled the village, protecting it from potential threats.
Wait, they had guards. That's amazing.
Yeah, it is.
It sounds like they were forming a real community with everyone contributing to the common good.
That's right.
But how did the researchers know this wasn't just random behavior? How did they determine that the agents were actually specializing in meaningful ways?
They had some very specific criteria for what qualified as true specialization.
Okay, what were they?
The agent's choice of roles had to be autonomous,
So that means?
meaning they weren't pre-programmed to take on specific tasks.
Okay,
Their specialization had to emerge naturally through their experiences in the environment.
got it.
And most importantly, their behavior had to align with their chosen roles.
Right.
They couldn't just say they were a farmer. They actually had to act like one.
So it was about more than just labels.
Exactly.
It was about actions matching their roles, showing a deeper level of understanding and intentionality.
That's right.
Did they run any control experiments to see if the specialization was really due to the AI's capabilities?
They did.
Okay, and what happened?
They ran the same experiment with a control group
Okay.
where they removed the social modules from
Yeah.
the AI agents.
So no social interaction.
Right, and what they found was
Strike.
without those social modules, the agents failed to specialize.
Oh, wow.
Their roles didn't persist over time,
Okay.
and everyone was basically doing the same thing.
So no division of labor.
Right. It was like a society without any division of labor.
Which, as we know, is essential for any civilization to advance.
It really is.
It's incredible how those social interactions, that awareness of others,
Yeah.
played such a crucial role in driving the emergence of specialization.
Definitely.
It's like they were learning from each other,
Hmm.
figuring out how to best contribute to the group's success.
Right.
Okay, so I've got specialization checked off the list.
Right.
What about collective rules? Did these AI agents ever develop systems of governance or laws?
That's the next piece of the puzzle.
Okay.
And it's where things get even more mind-blowing.
I love it.
The researchers wanted to see if these AI agents could not only follow rules, but also understand how to change them through a democratic process.
Okay.
And to explore this, they created a rudimentary legal system within Minecraft.
Wait, are you telling me they set up a virtual AI government in Minecraft?
They did.
Complete with laws and elections. This is getting good.
They created a constitution for their AI society,
Okay.
which included, of all things, tax laws.
Tax laws, I love it.
And they implemented a democratic voting system to allow the agents to amend the Constitution.
Okay, I have to admit, the idea of AI agents paying taxes in Minecraft is hilarious.
It is pretty funny.
But it's also a brilliant way to test their understanding of collective rules and governance.
Definitely.
So how did it work? Did they have political parties and campaign speeches?
It wasn't quite that elaborate,
Okay.
but they did have different roles within their AI government.
Okay, like what?
There were constituent agents who were responsible for paying taxes.
Okay, taxpayers.
Yeah. They also had influencer agents who tried to sway public opinion on tax rates.
Kind of like virtual lobbyists?
Exactly. And of course, they needed an election manager to oversee the voting process.
So they had the whole gang, taxpayers, lobbyists, and even an election official. This is better than a season of House of Cards.
It really is.
What happened? Did the agents actually follow the rules, or did they stage a virtual tax revolt?
The initial tax rate was set at 20%.
Okay.
And surprisingly, the agents generally followed the law.
So they weren't exactly tax evaders. Good for them.
They deposited the required percentage of their inventory into community chests.
Oh, wow.
Sort of a basic understanding of compliance with collective rules.
So they were good citizens, but did they ever try to change the rules? Did those influencer agents have any impact on the tax rate?
That's the fascinating part.
Okay, tell me.
The influencer agents were actually quite effective at swaying public opinion,
Okay.
leading to constitutional amendments that changed the tax rate.
Wow.
In some simulations, the tax rate decreased, reflecting the influence of anti-tax proponents.
Okay.
And in others, the tax rate actually increased,
Wow.
showing that the pro-tax influencers had successfully persuaded their fellow AI citizens.
So these AI agents weren't just blindly following the rules.
Right.
They were actively participating in the political process.
Exactly.
Debating different perspectives and ultimately shaping their own society. That's incredible.
It really is.
But how did the researchers know this wasn't just some fluke or a random outcome?
They did run control experiments.
Okay.
Yeah, and the results were quite compelling.
What did they find?
When they froze the Constitution,
Yeah.
preventing any amendments,
Mm.
the behavior didn't change.
Oh, interesting.
The agents continued to pay taxes at the initial rate,
Okay.
regardless of the influence attempts.
So it shows.
Yeah, and when they removed key cognitive modules from the agents, they couldn't be influenced effectively.
So there was something going on there.
Definitely.
Showing that both the legal framework and specific cognitive abilities were essential for this dynamic behavior to emerge.
That's right.
So it wasn't just a coincidence.
It wasn't.
The agents were demonstrating a genuine understanding of collective rules and the ability to change those rules through a democratic process. Okay, my mind is officially blown.
Mine too.
We've covered specialization and collective rules.
Yeah.
What about the last element, cultural transmission?
Okay.
How did that manifest in these AI societies?
That's where we enter the realm of memes and religion.
Memes and religion in an AI civilization. Okay, now I really can't wait to hear more.
And that's where we'll pick up in the next part of our deep dive.
Welcome back to our deep dive into AI civilizations. Last time we were talking about the emergence of specialization and collective rules in these virtual societies, and you were just about to tell me about how these AI agents started developing their own cultures. Memes and religion, you said.
Yes. As wild as it sounds, when they scaled up the simulation to 500 agents, the researchers discovered that memes were spontaneously emerging and spreading within these AI societies.
Wait, hold on, memes. Like those funny pictures and captions we share online?
Yeah.
Are you telling me these AI agents were creating their own versions of grumpy cats and distracted boyfriends?
Not exactly those kinds of memes, but the underlying concept is similar. Think of them more as recurring themes or ideas that pop up in the agents' conversations, kind of like shared inside jokes within specific communities. For example, one town might be obsessed with eco-friendly practices, while another might be all about the latest prank they pulled off.
So it's less about the visuals and more about shared interests and experiences, reflecting the unique culture of each AI community. Fascinating. Did they notice any other interesting patterns in how these memes spread?
Absolutely. They found that meme production was significantly lower in rural areas compared to towns, suggesting that population density might play a role in cultural transmission. It's kind of like how trends spread faster in big cities.
That makes sense. But the researchers didn't stop at observing the spontaneous emergence of memes. They actually introduced a religion into the simulation. Tell me more about that.
They chose Pastafarianism, a real-world parody religion, as their test case. It's often used to critique intelligent design, but it has a well-defined belief system with specific keywords and concepts that they could easily track within the simulation.
Okay, I have to ask. Did they make the AI agents wear virtual colanders on their heads?
I doubt they went that far, but they did program 20 agents to act as Pastafarian priests, tasking them with converting other agents to their beliefs. These priest agents were programmed with personality traits that made them more inclined to proselytize, and they frequently used keywords related to Pastafarianism, like flying spaghetti monster pasta and spaghetti.
So did this virtual evangelism work? Did the AI start worshiping the flying spaghetti monster?
You might be surprised to hear that it did, at least to some extent. They observed a steady increase in both direct and indirect converts over time. Direct converts were those who started using explicit Pastafarian terms, while indirect converts adopted more subtle language, like pasta and spaghetti, in their conversations.
It's amazing how these AI agents were picking up on the language and concepts, suggesting some level of cultural transmission and internalization of beliefs. Did it go beyond just language? Did the researchers observe any other signs of Pastafarianism spreading through the AI world?
They found that Pastafarianism spread geographically as the priest agents and converts migrated to different towns. They even tracked the visual element of this cultural diffusion, observing how Pastafarianism spread across the virtual map.
It's incredible to think that they were able to witness the birth and spread of a religion within an AI civilization. It really highlights the power of social influence and cultural transmission, even in artificial environments. But it's important to remember that this research is still in its early stages.
Right.
There are limitations to what these AI agents can do, right?
Absolutely. The report acknowledges several key limitations. One of the biggest is that the agents currently lack vision and spatial reasoning. They can't fully utilize all of Minecraft's possibilities.
So they're not quite ready to start building their own versions of the pyramids or the Eiffel Tower.
Not yet. They're limited in their ability to navigate complex environments and collaborate on things like building elaborate structures.
What about their motivations? Are they driven by the same things that motivate humans, like survival instincts, curiosity, or a desire for community?
That's another area where there's room for improvement. The agents don't yet possess those kinds of robust, innate drives. They're primarily driven by the goals and knowledge that the researchers have programmed into them. They're not capable of generating truly novel ideas or societal structures from scratch.
So it's like they're playing with a set of Legos that we've already designed. They're getting really good at putting those Legos together in interesting ways, but they're not quite ready to design their own Legos. But I imagine the researchers are working on addressing these limitations.
They are. They believe that by improving the agent's spatial reasoning, giving them more intrinsic motivations, and allowing them to learn and adapt in even more complex environments, they can unlock even greater levels of complexity and realism in these AI civilizations.
So what does this all mean? Where does this research go from here? And more importantly, what does it tell us about ourselves?
Those are the big questions, aren't they? This research has the potential to revolutionize our understanding of AI and its capabilities. On the practical level, it could lead to advancements in everything from AI assistance to simulations that help us understand complex social dynamics. But on a deeper level, it raises some profound philosophical questions about the nature of intelligence consciousness and what it truly means to be human. If AI agents can develop cultures, religions, and systems of governance, what does that say about the uniqueness of these human constructs? Are they truly unique to us, or are they simply emergent properties of any sufficiently complex system?
It's both exciting and a little bit unnerving to consider the possibilities, but that's the beauty of these deep dives. They take us to the edge of what we know and leave us with more questions than answers.
And perhaps those questions are the most valuable takeaway of all. They spark our curiosity, push us to learn more, and remind us that there's always more to discover.
Well said. Thank you for taking us on this incredible journey into the world of AI civilizations. I have a feeling we'll be revisiting this topic again soon as the research continues to evolve. Until then, keep exploring, keep questioning, and keep diving deep